Welcome to The Explainer. Today, we are diving headfirst into the AI gold rush. You know, it's a story that's moving at incredible speed. The stakes are super high, and honestly, it's full of deep, deep mysteries. So let's try to make some sense of it together.
You've probably played around with an AI, right? But the world behind that simple chat box, well, it's this chaotic, incredibly exciting place. It really is a modern-day gold rush. Everyone is racing to stake their claim. But the crazy part is, the landscape is literally changing under our feet every single day.
And just to give you a sense of that insane pace, take a look at this list. Now don't worry about all the jargon here. The point is, these are all major research papers from a single week. Yeah, we're talking about AIs that can teach themselves, AIs that can decipher animal sounds, even breakthroughs that are rewriting the fundamental rules of computing. It's a genuine Cambrian explosion of new ideas.
So, what is really going on here? With all this frantic activity, how do we make sense of it all? You know, if we look past the hype, what does this new frontier actually look like? And more importantly, what does it mean for us? Okay, so first up, let's look at where people are actually striking gold. Because it's not just happening in research labs anymore. No, the real rush, the real action, is in applying this tech to the real world, and it's happening right now.
And I mean it when I say this isn't just a Silicon Valley thing. Get this. This quote is from a job posting by ELF Beauty, a cosmetics company. They're hiring engineers right now to build things like recommendation engines and forecasting models. The gold rush is absolutely everywhere.
And we're not talking about abstract theories. This toolkit here, it's pulled right from that same job description. These are the actual picks and shovels of the AI gold rush. We're talking about things like RAG, that's Retrieval Augmented Generation, which lets an AI pull in live, up-to-the-minute information to answer questions. Or multi-agent systems, where you have different AIs basically working together as a team to tackle really complex problems.
The applications are also getting incredibly high stakes. I mean, take legal contracts. There's a benchmark called Contract Eval that's training AI to do something pretty remarkable. It spots huge financial risks buried deep inside dense legal documents. It can flag things like uncapped liability or tricky IP ownership clauses. You know, the needles in a haystack that could save or cost a company millions of dollars.
So, with so much on the line, the prospectors need more than just shovels. They need a way to, assay their findings. It's one thing to build one of these models, but how do you measure what it can actually do? How do you know if you've struck real gold or if it's just fool's gold? And this is a massive challenge, because any standard test you write could be totally obsolete tomorrow. But a really fascinating new framework called SCATE has this radical solution. It says, stop trying to test the AI yourself. Instead, make the AIs test each other. The way SCATE works is it basically turns evaluation into a competitive game. So one AI is the task setter. It comes up with the challenge it thinks it can solve. Then other AIs try to solve it. But here's the brilliant twist. The setter is actually incentivized to create questions that its rivals can't answer. It's just a really clever way to force these models to show their unique strengths and weaknesses.
And this whole competitive setup, it reveals something nobody really expected. It turns out that the skill of asking a really good, hard question is totally different from the skill of answering one. Some models are just brilliant at creating challenges that stump their peers, even if they aren't the best at solving problems themselves.
What it boils down to is that the models learned to play to their own strengths. They actually started generating questions that were tailored to their own kind of private knowledge. The researchers call this self-preferencing. And yeah, it's a primitive form of strategic thinking, but it's undeniable, and it just emerges out of the game itself.
And this is where our journey into the gold rush starts to get, well, a little weird. We're moving away from just engineering, building tools, and we're wandering into this territory of profound scientific and maybe even philosophical mystery. We are finding ghosts in the machine.
This quote from researcher Vladimir Havlik really says it all. These AI systems have gotten so complex that we can't really treat them like programs we just write and understand anymore. We actually have to study them the way we'd study a weather system or a coral reef, as these special natural phenomena that have their own rules we have to go out and discover.
And one of the biggest mysteries out there is this phenomenon called grokking.
The term itself comes from this classic sci-fi novel, and it describes this bizarre moment of insight, this flash where a model suddenly leaps from just memorizing data to actually understanding the deep patterns hidden inside of it.
This timeline just shows how strange grokking really is. Okay, so the model trains, it gets really good at memorizing its training data, and then it just flatlines. It looks for all the world like the training is done, it's over. But then, long after learning seems to have totally stopped, its ability to generalize to new, unseen problems suddenly, unpredictably, just spikes. It's like a phase transition from pure memorization to something like understanding.
So this all leads us to a really fascinating and kind of humbling challenge. We know how to build the machine. We know the math behind every single little neuron. But we don't fully understand why the system, as a whole, develops these new emergent abilities. We are, in a very real sense, creating things that we do not completely understand.
So, where does all this leave us? We're standing here on the edge of this new frontier. We've got a map in our hands, but most of it, it's still blank. We're seeing immense practical value on one hand, but we're also running into these deep, deep mysteries on the other. But the potential rewards of this gold rush, they're almost beyond comprehension. Just think about education for a second. This number, 244 million, that's how many kids and young people are out of school across the world. AI has this incredible promise of personalized tutoring that could reach every single one of them. The potential here is just enormous.
And the evidence really suggests we're building something way more interesting than just clever parrots. I mean, the latest research is all about models that are designed to teach themselves, to evolve their own reasoning, to improve through self-play. We are building systems that are designed literally from the ground up to learn and create all on their own.
Which brings us to this one last, really provocative thought from the researchers who built Escade. The very tools we're building to measure AI are themselves revealing the very first signals of strategic behavior. So we're not just mapping a new continent, we might actually be witnessing the first stirrings of its native inhabitants. And what comes next? Well, that part of the map is still a blank page.